How effective is interleaved practice for teaching statistics? Stats is hard, and there are a lot of reasons why stats is hard, and the two reasons I'm going to focus on here are conceptual misunderstanding and conceptual misapplication. So how can we improve students' conceptual understanding and hopefully by extension their conceptual application? Something we can do is we can use interleaving to help students learn the concepts. Interleaving has been used to successfully teach concepts and categories in the past and is typically more effective than blocking. To briefly explain what each of these things are, if we consider the letters A, B, and C as three different concepts, if we were to learn those concepts via interleaving, we might structure the trials like this. If instead we were to try to learn those same concepts via blocking, we might structure the trials like this. And so in our task, what we did is we tested to see which of these structures would be more effective for learning and applying stats concepts. We predict that interleaved practice would result in better overall performance at test, and specifically better performance on the applied problems at test. Here's some information about our final sample. You can pause here and take a look at it. So the first thing we did is we had everyone read 3 short lessons on common stats concepts, 1 on central tendency, 1 on dispersion, and 1 on samples and populations. Next, we randomly assigned people to complete either an interleaved or a blocked practice phase. 7 days later, we had them complete a test phase. Here's an example of what a basic recall question might look like, and you can pause here and take a look. And here's an example of what an applied problem might look like, and you can pause here and take a look. So the first thing we looked at was the total proportion correct, and the only significant effect we observed was an interaction between practice condition and phase, such that students in the interleaved condition performed worse than students in the blocked condition at practice, but performed the same as one another at test. And this lack of a difference between the practice conditions at test was contrary to our first hypothesis, so we did not find support for our first hypothesis here. The next thing we looked at was the proportion correct on each type of question separately. And although we had no a priori hypotheses about what any kind of practice effects would look like for the basic recall questions, we do include them here for comparison. So for the basic recall questions, we did not observe any significant effects anywhere. And the same was also true for the applied problems. We didn't observe any significant effects anywhere for the applied problems either. And again, this lack of a difference at test for the applied problems is contrary to our second hypothesis. So we did not find any evidence supporting the idea that interleaving would help students apply concepts. So interleaving didn't seem to help. So what might have happened? The task was potentially too hard. We may have asked students to learn too much information in too short of an amount of time. Additionally, some of the test questions were novel, meaning they did not appear during the practice phase, and in that way, the test phase is not only just a recall test now, it's also a generalization test or a transfer test, and that might have made it unnecessarily difficult. Something else that might be going on is that the existing contexts that interleaving has been studied in may not generalize all that well to stats. So, for example, a lot of existing studies of interleaving used very concrete stimuli. They used things like paintings, pictures of animals, little dot diagrams, arrangements of lines on a screen. All those stimuli are very concrete. They're directly perceptible, and that is not the stimuli we used in this study. In the task we did, all of our stimuli were verbal, and not only that, but the concepts we were asking people to learn are a little more abstract. So something like central tendency, it's a little more abstract. In a similar vein, a lot of existing studies of interleaving, even ones that did use kind of more, arguably kind of more abstract concepts, so for example, algebra or fractions, they're just arguably simpler than what we're having students do in an undergraduate level stats class. And so the combination of those two things might make it harder to generalize from these past studies to what is likely to happen when we try to use interleaving to teach statistics. So something we're interested in looking at in the future is in what context is interleaving effective for teaching complex abstract concepts. Again, it's that combination of the complexity and the abstractness that I think is a particularly interesting facet of statistics. So thank you to everyone here at CAUSE and my lab and Lindsay Richland's lab. And there is some supplementary slides that come after this, and so if you're interested, you can take a look at that on the slides that are posted on the CAUSE website.